This is section 3 of biology. We're looking at homeostasis. Now, homeostasis, stop laughing, Vanessa, you're putting me off. Homeostasis is the maintenance of a constant internal environment. Now, what this means is that inside of your body has to stay within narrow limits for certain things. Examples would be your pH, which is how acidic or alkaline your body is, your blood sugar level, the amount of water in your body, and the other one is the regulation of temperature within your body. Okay? Now, your body temperature is roughly about 37 degrees centigrade, and that's kept within narrow limits by homeostatic mechanisms inside your body. The one we're going to focus on is the water balance within your body. Now, water can get into your body in a number of different mechanisms. So, for instance, Molly's going to come up and write down one way in which water can get into our body. One way in which water can get into our body. Yep, very, very good. So we can drink it. Excellent, thank you, Molly. Vanessa's going to give another method.
You spelled it wrong.
Susan!
Very, very good. Now, those are the two main mechanisms. Yes, Rach, what was you going to say?
One other way that it can
Yes,
get
it
into
is. And that is, it is the metabolism of food, okay? Sometimes when we break down certain foodstuffs, we actually produce water as a byproduct. Now, where people get confused is where water is removed from the body. Now, obviously, we can remove water by crying, by vomiting, etc., etc. That doesn't really count for these purposes. Chloe, do you want to give us a method? Very good. We have sweating. Okay, we also have Connor again.
Thank you.
Yeah, excellent. Production of urine. Okay, this is called excretion. We also lose some water, very good, through breathing. Okay, so those are the main mechanisms by which water is lost through the body. Now, we need to understand how the water balance in the blood is maintained. Now, this is quite complicated. So we're going to have to use different parts of the brain. We have a section of the brain called the hypothalamus. Now, inside the hypothalamus, there are salt receptors. And what the salt receptor will do is detect the salt concentration of the blood. So as the blood goes through the salt receptor, the salt concentration in the blood is detected. Now, if the salt concentration is too high, this would imply that the body is either what? Dehydrated or dehydrated, okay?
No, there would be less holes inside the...
So if we have dehydration, there is another part of the brain called the pituitary gland. Now what this releases is a hormone called ADH, which is anti-diuretic hormone. Now we remember it, it's not entirely correct, but we remember it as adholes. Because what ADH does is increase the permeability of the collecting duct. In effect, what it does is causes more water to be reabsorbed back into the bloodstream. If you reabsorb more water back into the bloodstream, the level of salt concentration in the blood is going to go down and become more hydrated. Now, as a result of this, the urine is going to change because the urine is now going to be concentrated, and the volume of the urine is going to be low. Okay? Now the reverse of that, quite simply, if we was extremely hydrated, the salt receptors would detect the fact that there is a lot of water in the actual body, which means it would release less ADH from the pituitary. If it releases less ADH, we reabsorb less water, which means more water passes out of our system, which means we produce a high volume of very, very dilute urine. Okay, it's very, very watery and it's very, very clear. Now, the last thing you have to remember on this are the effects of alcohol and also ecstasy, because alcohol and ecstasy affect the levels of ADH. So, if you drink alcohol, what it does, it will reduce the output of ADH. So in effect, if we reduce the output of ADH, this means less water is reabsorbed, which means the volume of the urine is going to be higher and it's going to be very, very dilute. Ecstasy will do the reverse, okay? Ecstasy will increase the level of ADH. So, in effect, if somebody is taking ecstasy, it increases ADH, which means it will reabsorb more water. If it reabsorbs more water, then more water is taken into the body, okay? And this is where the danger arises. Okay.